Hello everyone, my name is Rituja Mishra and I am a final year diploma student currently pursuing my internship at iBase. Today I am presenting a project that is plant disease detection system. It is developed using Python and it is based on the concepts of deep learning. I have implemented a convolutional neural network, that is the CNN model, to detect the disease in the plant leaves from the images. In this video, I will give you a proper demonstration of this project and give you a proper explanation and highlight its key features. So let's get started.
Here, the main objective of this project is to identify whether a plant leaf is healthy, affected by powdery disease or rust disease by using the image classification. Firstly, I have imported all the required libraries. I used OpenCV for reading and resizing images, NumPy for array operations, label encoder for converting disease names into the numbers, then TensorFlow Keras for creating and training the CNN model. I have chosen sequential model and the layers I have used are dense, conv 2D, max pooling 2D and flatten layer. Here I created a function called load dataset. Instead of writing the same code again and again for training and testing datasets, I created one function and reused it. This function reads all the folders like healthy, powdery and rust, and it loads every image and it resizes it into the 128 by 128 pixels and stores the images in one list and the labels in another list and finally returns both of them. After that, I gave the training dataset path and called the function. Then I converted the image list into a NumPy array because TensorFlow works with arrays. Next, I normalized all the pixel values by dividing them by 255 so that all the values become 0 and 1. Finally, I used the label encoder to convert the disease names into the numerical values. In the same way, I loaded the testing dataset and normalized the testing images and converted their labels using the same label encoder. Using the same label encoder, these testing images are used to check the performance of my model. Then, here I created my CNN model using sequential, which stacks the layer one after another. First, I added Conv 2D layer with 32 filters to extract important features from the leaf images. Then I used the max pooling 2D layer to reduce the image size. Again, I added Conv 2D layer with 64 filters and another max pooling layer to learn more complex features. After that, I used the flatten layer to convert the data into one dimension. Then I added dense layer with 128 neurons for learning and then finally an output layer with 3 neurons because my project contains 3 disease classes. After the training was completed, I evaluated my model using the testing dataset, testing loss, and testing accuracy, which tells us how well the model performs on new images. Here, I tested my model by giving one leaf image. The image is resized and normalized and passed to the trained model. The model predicts the disease and displays the final output. Finally, I saved the trained model as a .keras file. This helps me use the model again later without training it from the beginning. Now let's run the code. It might take some time. So let's see. We can skip the warnings for now. Here we can see all the disease classes and the number of images loaded for each folder. For now, it's showing healthy. Now let's see. Now let's just wait for it.
Powdery, rust, 1322 images and labels which has trained. Minimum and maximum pixel values also I have printed. So the summary of the sequential model I have printed. These are the training epochs. During every epoch, the model gradually learns the important features of the images and improves its accuracy.
These epochs are in 42 batches. Total 10 epochs I have taken. So, after training, the model displays the testing loss and testing accuracy. As I have given one image here as an input, it predicted the Powdery disease, which is correct. The model has saved so that we don't need to train it again. Now I've created another Python file called predict.py. The purpose of this file is to predict disease using the already trained model. So there is no need to train model again. I have downloaded a disease leaf image from internet to check whether the model predicts correct disease. So let's just run the code. Let's enter the image path. Now we can see the prediction probabilities for all the disease classes. The class with highest probability is selected as the final prediction. In this case, the model has predicted rust disease, which matches the image correctly. This completed my plant disease detection project using convolutional neural network. Thank you.